Okay, in this video we're going to look to apply the method of trigonometric substitution to integrals typified by what we have in these examples here. Now the integrals that we have applied to which we have applied trigonometric substitution so far did not have the x term, so they were of the form, say, x squared minus a squared minus x squared, or x squared plus a squared. So in all cases the x term was absent. Now what you're going to notice with the current quadratic expressions is that they are all either trinomial or the x term at least is there. Like this one has got only two terms, but you have the x squared term and the x term. So for this one, before we can apply trigonometric substitution, typically we need to start by completing the square. So if you are not up to speed or you're completing the square is a bit rusty, you might want to go and brush that skill up. We are going to give you a few details, but it's not going to be just a primer on completing the square. So take this a, for instance. Just out of interest, this is a rational function. We've got a polynomial divided by another polynomial. So we could think of applying integration by partial fractions. However, the problem with this one is that we're going to find that it is not factorable. A quick criteria to see if a quadratic is factorable or not is this one. If the discriminant is less than 0, then definitely we know it cannot be factorized. In this case, the discriminant is going to be negative 6 squared minus 4 times a times c. This is going to be 36 minus 52. This is going to be, so this x squared minus 6x plus 13 is definitely not factorable, and so using integration by parts wouldn't work. So what we're going to do is we're going to complete the square. So in completing the square, all we do is we write the first two terms. We bring this sign down here, so it's going to be x minus, then it's going to be minus half of this number here, which is the coefficient of x, and then squared. Maybe let me use some color coding here. So the bits that are new I'm going to write in a different color. So this changes to x minus 3. This one is exactly what we had before, and then what we do here is this is going to be squared. Okay, and then all we do is we always subtract the square of this number here, so that's going to be minus 9. Okay, and then that's that. We don't expand these brackets here, so that's just going to be x minus 3 squared. This is going to be plus 4, and then we are done completing the square. So this integral we can write as dx over x minus 3 squared plus 4. And then what we're always going to do is we're going to make u the expression inside the squared brackets. So here x minus 3 we're going to make u, so du is going to be dx, and so this thing is now going to be written entirely in terms of u is going to be du in the numerator. In the denominator it's going to be u squared plus 4. So as you can see, by so doing we now have a quadratic in the denominator where the middle term or the u term is absent. Now from what we did in parts 1, 2 and 3, we know then that this is going to be a tangent substitution, and our a is 2, so du is going to be 2 secant squared theta d theta. So our integral is now going to be 2 secant squared theta d theta all over u squared is going to be 4 tangent squared theta plus 4. This is now going to be 1/2, which is okay, maybe not yet. So it's going to be 2 secant squared theta d theta. We factorize 4 here, going to be tangent squared theta plus 1. And then now the 2 over 4 is 1/2. In the numerator we've got secant squared d theta. Tangent squared plus 1 is also secant squared. So you are going to notice that this is cancelling out. So we just have 1/2 into the integral of d theta. And so this is going to be 1/2 theta plus c. Then we've got to trace our steps back. Notice we've done 2 substitutions. So first of all, theta from here. So from here you can see that tangent theta is u over 2. So theta is going to be inverse tangent u over 2. But then our original variable is x. In terms of x, u is x minus 3. So then we're going to write this as inverse tangent 1/2 into x minus 3, and this is our final expression. Right, so that was example number A. In example number B, we have the integral of x dx all divided by square root of 4x minus x squared. This one is not a rational function, so we don't even want to start contemplating in terms of partial fractions. So we just get straight away with the completing the square. Now notice whenever we complete the square, we need the coefficient of x squared to be 1, which it was in this case here. In this case it is -1, so we're going to factor out -1 and then write this as x squared minus 4x. And then once we've done that, we can now complete the square inside the square brackets. So if we use that procedure again, so the first 2 terms are now going to look like this. Then in this case there is no constant term. Then we're just going to subtract the square of this. So that's going to be minus 4. And then the completing the square process is done. Then afterwards we remove the square brackets. So when we do that, then this thing is going to look like this. You can actually confirm by removing brackets here and simplifying, and you're going to find that this works out to exactly that same thing with what we did earlier. If you open brackets here and simplify, this thing will work out to x squared minus 6x plus 13. All right, so then our integral is going to be equal to the integral of x dx divided by the square root of 4 minus x minus 2. And then as before, we're going to make u the term inside the squared brackets. So this time u is going to be x minus 2, and then du is just going to be dx, because the derivative of the right hand side is just 1. Okay, but here we also have this x term here, so we're going to need to write x in terms of u. So if we take 2 to the other side, then x is u plus 2. So our integral is now going to be u plus 2. Dx is du. In the denominator, we're going to have 4 minus u squared. This is now looking like the expressions we had in the previous videos. So we can now apply a trigonometric substitution. Because the squared term is negative, it is going to be sine. Because we have got 4 here, which is 2 squared, it means our a is 2. So du is going to be 2 cosine theta, not squared, just cosine theta d theta. U squared is going to be 4 times sine squared. So our integral is now going to be u is 2 sine theta here, and then plus 2. Du is 2 cosine theta d theta, and inside that square root we're going to have 4 minus 4 sine squared theta. There is 2 here and there, so that 2 we can factorize. It's actually 4. Then in the numerator we're going to have sine theta plus 1 times cosine theta d theta. Inside the square root we can factorize 4, so that is going to be square root of 4 into 1 minus sine squared. 4 now we can take outside the square root, so it's going to be 2. Square root 4 is 2 sine theta plus 1 cosine theta, and then 1 minus sine squared is cosine squared. So it's going to be square root of cosine squared, which is of course just cosine. So we've got sine theta plus 1 cosine theta d theta, all divided by cosine theta. This now cancels out, so we just need to integrate sine theta plus 1. Okay, integral of 1 is theta. then integral of sine theta is minus cosine theta plus c. Okay, so that is the integral, but it's in terms of theta. So we need to rewrite this in terms of u first, then in terms of x. In terms of u, from here, sine theta is u over 2. If sine theta is u over 2, it means in our right angle triangle, you've got u here, you've got 2 here. So this is going to be 4 minus u squared. Okay. So what it means is that this is going to be 2 into sine theta is u over 2. So theta is inverse tangent u over 2, inverse sine. Then cosine theta is going to be the adjacent over the hypotenuse, and then plus c. Then this is going to be 2 times inverse of u in terms of x is x minus 2. So we're going to have here we're going to have 1/2 into x minus 2. Then take away this 2, and this 2 is going to cancel out. So that's just the square root of 4 minus u squared. 4 minus u is x minus 2, and then plus c. However, we're just going to recall, I'll show you this in a moment. Sorry, this is minus. We're going to recall that 4 minus square root 4 minus x minus 2 squared is equal to 4x minus x squared. So this thing is going to be minus the square root of 4x minus x squared plus c. Alright, so this video, we're going to bring it to an end here. We are going to continue with the next 2 examples in the next video. If you have got any questions or any comments on what we are doing, please feel free. We will appreciate to see your questions in the comment section. We're hoping this is useful. Please do not forget, of course, to subscribe to our channel and like the video. Right, thank you. See you in the next video.